In this segment, we'll look at the SQL insert and delete statements for adding rows to a table and for removing them. To add new rows to a table, we use the SQL insert statement. Now let's start with a fresh load of courses1.sql, and let's do an insert statement to add a new row to its person table. Now this is the simplest form of insert. As you can see, it starts with insert into and then the table name, and then the keyword values, and then it follows with one or more parenthesized lists of values, comma separated, each list having one value for each column in the row. We have only one such list in this example. As you can see, after running this statement, person has a new row. The values in each list must appear in the same order that the columns would in a show columns listing, or equivalently the order they were declared in create table, or the order they would show in the result of a select star. It's all the same order. Values must match the column types. Quoted strings for string or enum or date types, and numbers for numerical types, like the ID. As you can see in the example, null is also an allowed value for columns that permit nulls. And by the way, inserting raw binary data in blob fields takes some SQL functions we haven't yet discussed. We'll leave that for later. Now, if you have several parenthesized lists, then the lists themselves are comma separated. There are plenty of good examples of this in courses1.sql, which uses a single insert statement for each table. Lines 52 through 62, for instance, down here, do a single insert statement to fill the person table. And as you can see, it has a value list for each row, comma separated as advertised. Now, let's talk a bit about inserts and constraints. Insert statements must comply with all constraints. For instance, if I write insert into person, values 11, Jones, Bill, and so forth, that will fail in two ways, both having to do with some constraint. And question one, what two ways? What two constraint rules already discussed does this new insert violate? You can always just run it to find out, but try to predict first. And in any event, do run it and fix the problems before going on. Coming back to from a pause there, well, we gave gender a null value here, but gender is declared not null. And the primary key ID does not allow duplicate values. We already have an 11 from the prior insert. So we're going to get errors. And we could fix it, of course, by filling in a value for the gender and changing the ID up to 12 instead. And when we do that, we find that we do have 12 lines in person. Now, let's also look a little bit at column-specific inserts. In some cases, you don't want to supply values for all the columns of a row. An alternate form of insert lets you add a parenthesized list of columns that you want to set after the target table name, and then supply only values for those columns in the lists following the keyword values. That looks something like that, where we're setting just the last name, first name, gender, and department values. So, question 2. Run this command, and then do a select star from person. What happens to the unspecified columns? And in particular, the result for ID is interesting. And if you review the declaration for that column on row 7 of courses1.sql, one keyword in particular stands out as the likely reason. So coming back from a pause, if you tried it out, you should have found that the unspecified columns were set to null. But the ID gets filled in with the next ID in order. And not surprisingly, that is due to the fact that in the declaration we have an auto increment keyword. It's pretty common to see auto increment on integer primary keys, since assigning the next unused value is almost always the right thing to do. So, question 3. What do you think would happen if we ran this command here? You can try it, of course, but first make your best guess as to the result. Coming back from a pause, it would almost work, and it would set all columns to null except for ID, which would get the next value, but gender is declared not null, so it fails. And something interesting there, the error message complains about a missing default value. Now, this suggests that if we had declared a default value for gender, maybe like this, then the insert would have worked. And that's correct. It would use the specified default for the missing gender data. In general, you may omit any column in a column-specific insert as long as the column is nullable or has some default specification, for instance by auto increment or by a declared default value. Okay, now let's talk about deleting rows. Now that we know how to insert rows, we can delete a few. We can remove the just added Jane Smith, for instance, via the statement delete from person where ID equals 13. Now, running it, you can see that she's been deleted from the table. The delete command is pretty simple. It takes the form delete from and then the table name, followed by a where clause specifying the rows to delete. And you already know from the prior segment that omitting this clause will delete all the rows. So question 4, write and execute a statement to drop Juliet Logan, up here number 1, using her first and last name instead of her ID number. And coming back from a pause, what you should have come up with would be delete from person, where first name equals Juliet and last name equals Logan. And running that, you can see that we now have just 11 rows in person, and Juliet is not there. Now, write and execute a statement to drop Terrell Arzt, number 2 there, using his first last name instead of his ID number. And it's okay if this fails. We'll talk about it. So again, coming back from a pause, what you should at least have tried was this. Delete from person where first name is Terrell, last name is Arzt. But we got a problem here. It fails with a foreign key complaint regarding the teaches table. If you go out over here, something about teacher ID. Well, when you think about it, that makes sense. If there are rows in teaches referring to the person row for Arzt, then their foreign keys will be left dangling by the deletion of Arzt. Let's see how many teaches rows were referring to Arzt. His ID is 2, of course. Looks like 2 of them. So just blowing Arzt away will leave those foreign keys dangling, and thus the error. Now, Logan wasn't a teacher, so there's no issue with the foreign key in table teachers, but she did have classes she was taking as a student. So question 6, why weren't there complaints about dangling foreign keys in the takes table, which is used by students, of course, when we deleted Logan? And what happened to the classes she was taking? Check the takes table to see if they're there. What explains the difference? Coming back from the pause, a quick check of the takes table shows that there are no longer any entries with student ID 1. And so, as you probably realize, this has to do with the cascade declaration for the takes table foreign keys right here. On delete cascade, for instance, on line 48 and 49. Now, you are allowed the same three options for dangling foreign key prevention on deletion as on update. Option 1, an error message and a failed delete, which is the default. Option 2, on delete cascade, which means that referencing foreign key rows get dropped from their table along with the rows from the referred table. This is what happened with Logan, of course. And then the third option is on delete set null, which leaves the dangling foreign keys set to null. Now, the cascade option is so named because it can ripple through many levels of tables. Let's say that table A is referred to by a foreign key in table B, and that table B is referred to by a foreign key in table C, as in the diagram here. In this diagram, a single row in A is referred to by 3 rows in B, arrow here, and that in turn, those 3 rows in B, are in turn referred to by 4 rows each in table C. Now, if all the foreign keys in question here cascade on delete, then deleting that 1 row in A also results in deleting the 3 rows in B, and that in turn results in the deletion of the 12 rows in C that refer to the deleted rows in B. Now, in the next segment, we'll add on-delete cascade options to the foreign keys in teaches, but for the time being, there is a way to get the same effect from a well-crafted delete statement. You can create a join in a delete and delete all the rows from the join. After the delete keyword, this statement lists the several tables from which to delete, since it's not an obvious choice of just one table anymore. It then uses a join to create combined rows of arths in person and all the rows in teaches that link to it. And it collectively deletes all those rows from both tables in a single action without leaving any dangling foreign keys.